Hello, community. Let's have a look at the complete ecosystem here of large language models, April 2023. So we start here in 2022. GPT 3.5 was released, and you could use GPT 3.5 with two different access paths. Either, like today, you have ChatGPT is more or less a free version you can use the access, or if you want to do it professionally, OpenAI has an own API for you where you have to pay to get access to run your things on an LLM and you get your data back. Beautiful. So the first access we have here a prompt. A prompt is simple, a line where you can type something in. We call here the intelligence you can apply here prompt engineering, because you can write a clever prompt. So instead of, hey, show me what you know about photosynthesis, you can write, give me a detailed explanation of the biological and chemical processing on a molecular level regarding photosynthesis. So, and of course, if you are a professional company, you can write a Python program so you can directly interact here with the API of GPT 3.5. This is great. It took OpenAI about 6 months to come up with GPT-4. GPT-4, as you can see in the size, is now able to handle text, images, and code. So if GPT-3 was about 175 billion trainable parameters, we expect now that the size of GPT-4, which is top secret, is about 500 billion trainable parameters. Let's work with this assumption. We have the same access to the system. There is a ChatGPT Plus. This is also prompt based. This costs you about $20 plus tax per month. If you are a professional, Bank of America, a company, and you need here massive access, OpenAI provides an API for you where you can write your little program and you have here an automated interface to GPT-4. This is where we are now in April 2023. But you know what? Let's look a little bit back, just 3 years, when in 2020, Google came up with also a specific model that is based on the transformer architecture. It was called T5, and T5 stands simple for text-to-text transfer transformer. And this model had a size of 3 billion trainable parameter and 11 billion trainable parameter. And at this time in 2020, this was quite impressive. So what happened next is that Google discovered that if you have your data here on the left side, the internet data, and GPT-3 and GPT-4 both have been trained on all available internet data, and of course we assume that they respected all intellectual property rights when they copied the data from the internet. You have data that are not available on the internet, and you see this here on the right hand side. You have special data that companies keep secret. You have special data that are your private data, your private photographs, your private medical records, your private whatever. But of course, we are focusing here on company data. If you are, for example, a biomedical company somewhere in the world and you have your research team, all your research, you do not put it for free on the internet. So there's a lot of special data that are private, protected, but you want to use this data if you're a company. So Google found out if they take now one piece here of this special data and for one task, and let's say this is a very special task, for example, a translation task, to go from, I don't know, the French language to a language that is spoken, I don't know, somewhere in the South Pacific. So you can be sure that there are not a lot of available internet data, but for one particular task and one task only, you want to have a very focused, special, high performance system. And they said, if we fine tune now here our training and all our systems here, GPT-3, GPT-4, have been pre-trained. Of course, they digested all the internet data according to the algorithms. And now with the training they have, they were able to perform tasks. But if you're not satisfied with just the pre-training, you can fine-tune now your system for one particular task. And this is what Google discovered and called it fine-tuning. And in 2022, Google came out with the FLAN T5 models. Now they had the same size as their T5 models, but FLAN stands for fine-tuned language models. So you see Google, of course, having access to Google Cloud computer infrastructure, they did not fine-tune it on one task, but they fine-tuned it on hundreds and thousands of tasks. So those happen in 2022. And you see now the data that we have on the internet and the data that we have here in companies that are highly protected data. You see, you want to use your company data to have access to hear this artificial intelligence of an LLM, of a transformer architecture for artificial intelligence. So people started to use this fine-tuning with their private data on their dedicated hardware. Now, if you think that about, let's just an imagination, GPT 3.5, you need about 1000 GPU on the Microsoft supercomputer cluster to train a GPT-3. Let's say GPT-4, we are somewhere in the bracket of 1000 GPUs to 10,000 GPUs as your hardware configuration that you are able to pre-train GPT-4. The real data are secret. And of course, if you have here access through either the prompt or through your API, your Python file, you are not given any information about what's happening inside of GPT-4. This is a black box for us that are paying to get access. And of course, talking right now in April 2023, you cannot even fine-tune here GPT-4 for your task because it is so already pre-trained that the fine-tuning here is currently not established. But I'm quite sure they will do it because you can ask for money. So beautiful. Next step. With this fine-tuning here, something interesting happened because in the last 1.5 years, you found out that you do not just can prompt engineer your way here with this free access, but you can do something that is called in-context learning. It is an advanced prompt engineering methodology, if you want, where you take now here a piece here of this non-public data set. You slice it up in tiny chunks. And then whenever you have, for example, here with ChatGPT Plus, where you have here the one line, you put in here one piece of information, and then you ask something. You put in a second piece of information, and then you put your question. So you can feed in 1, 2, 3, 4, 5 small trunk of information and then ask the system something. Since this here does not change at all the weights, the learnable parameter of the GPT-4 system, because it is top secret, you have something that is not a fine-tuning, because in fine-tuning, like here we saw in Google, all the learnable parameters, all the 3 billion parameters or the 11 billion parameters of the FLAN T5 model were learning on the new training data. This here are the training data, the special data that are for you in your company. Here, since you do not have access to GPT-4, the training learnable data here in GPT-4 do not change. This is something, imagine that you have this huge system and only on a very small, tiny surface area you can put in your question, and more or less only this information goes only to the surface area of your system, is interacting there, it is learning there for a very tiny amount, and you can get some result back. This is the beauty of in-context learning. And if you chain this together, you have methodology where people have developed methods that are free. You have to pay for them. So everything, when you chain here commands here for in-context learning, whatever you use it, here we are trying to interact and have a learnable surface area where our input data finally hit here GPT-4, but you are not able to learn to train the system on new data. Beautiful. But this, of course, opened somehow the box of Pandora, because people said, hey, I have an idea. Now, after Microsoft and Google, it's now 2023, there's now Meta. And Meta, you remember Facebook, developed an own model. No, it not developed a model, but it just trained a model on data. And they came up with their model they call LLama, and this model is available in 4 sizes: small, medium, large, XL. Or if you want, 7 billion trainable parameter, 13, 33, and 65 billion trainable parameter. Now, you see that the size here, compared this to GPT-4, is really, really tiny. But the advantage is that 7 billion is something you can somehow handle in your compute infrastructure, at home, in your company, because who can afford thousands of GPUs? Only Microsoft Supercomputer Center or Google Cloud. So here we go. Now we have since some months available this Meta Llama models. But of course Meta says, hey, our weights are top secret. So you have to fill out a form. You have to give us your address, your name, your email, telephone number. You have to write us your scientific publication. And then we decide if we grant you access here to our model. And without the weights, you have nothing. Now, it happens that somehow this information leaked, I don't know how, and it was available on the internet, and people suddenly used this because now they could build this model. Now, if there is one singular source of information for all the scientific community that are working now with Meta Llama models, is this, if you think about the risk that we have no idea about the leaking process by a company who wants to acquire market shares here in this particular area, I leave this discussion completely up to you. But suddenly we had models. Now, apart from the Flyant T5 that was open source by Google, we have here a secretive, but somehow somebody temporarily borrowed the data from the internet. And then this opened up something, because people discovered they need training data. They need a lot of training data. But if you have data that are intelligently configured, that have a lot of inherent information, you could use this data, this condensed, let's call it intelligent data, to feed those data to here the very tiny, small 7 billion parameter model. I mean, just look at the size difference of this little blue cube compared to GPT-4. But this is what 90% of the AI community has access to in hardware, because I will show you later on how much it costs to have just access to 8 GPUs that are able to handle this amount of data. So you see, people discovered, hey, great, I can, if I do not have now, for example, my secret company data, if I have a small set of data that has a particular form. Think about this, you want to write a poem. So you as a human, you sit down, you write a poem. And you come here now, you say, hey, GPT-4, In this interface, I show you a poem. Please write now 50,000 version of this poem. Change the verb, change the object, change the time, change the person in the poem, change the outcome, change the whatever you can change in a poem. It is just an example that you see. We have now this, let's call it intelligence here, that if you pay, of course, this is now a payable interface. If you pay, you get 50,000 similar poems back. And now with this synthetic, artificially generated data, we call this data self-instructed data, because we have one human instruction, or 100 human instruction to be better, and we self-create, we let the system self-create here 50,000 similar copies. Now, for our training now, and we use here this minimum system, if we use now 50,000 training data set, this is the right amount that we can now kind of fine tune our mini system here for a particular task. And this was done here by Stanford University, and they called their fine-tuned system the Alpaca system. Maybe you have heard about it. So this is the process how you have now access. You have some data, or you write some data. You make here an instruction. You ask GPT to create thousands of similar instructions, because we need a huge training data set to feed in, to start the training process of this tiny little model here. It needs tens of thousands of training examples to develop, if you want, the system intelligence of an LLM. And you come up with a new model, and Stanford University called it Alpaca. Now, you will notice that in the last weeks, you have a lot of models. You have Vicuna, you have GPT-4All, and in the next weeks, there will be a lot of models, but all follow the same path. You construct synthetic data out of GPT-4, and you feed it in as training data to the tiniest model we can imagine. And this is more or less the latest model. But, you know, if next week another company comes up with a next model, we will all jump to the updated model. So whenever you watch this, please fill in whenever you have here your company and the latest model, whatever it is called, instead of Llama. Of course, you can have now, since T5 is open source, I use T5 because here the Llama weights are semi-secret, semi-protected. No, they are absolutely protected, but there is a way that a research community can use it. So this is more or less the path where we are now in April of 2023. So you understand what is going on at the moment. And I have given you here some additional information concerning the hardware infrastructure you need. But you see, this path here to fine-tune this model with this huge data set here, you have two options. You have, if you have not enough money to afford the brilliant compute infrastructure, that you go to Microsoft and you rent there a mini supercomputer, you have a way that is called PEFT, parameter efficient fine-tuning. And the other option is the classical fine-tuning. So we are talking about fine-tuning methods, but in the first fine-tuning methods, we say we understand our technological compute infrastructure is so reduced that we have to freeze the model and only work with less than 1% of the weight tensors in the layers of our transformer architecture of our large language model. So simply because we need huge compute infrastructure, we find a way to reduce the trainable mathematical objects to less than 1% of what it really is. Now, the classical alternative, if you have the infrastructure, if you have the money to rent here supercomputers, you go the classical fine-tuning. All the weights of all your tensor operation in all layers of your transformer architecture, of your large language models, are set to trainable and will be included in the mathematical update. So 100% of our tensors, and AI is tensor operation, matrix multiplication, will be updated. So this is the optimal tuned model. For this, since now instead of 1% of our mathematical objects, we train now 100% of all our mathematical tensors, we need a huge infrastructure. And this is typically a system that we call from NVIDIA an H and Hopper architecture, an H100 GPU, Tensor Core GPU, and we need 8 pieces of them. And they are bundled here in this configuration. And Alpaca, for example, by Stanford University, was done exactly in the way number 2. They used here the classical fine-tuning after they generated this synthetic data using the intelligence of GPT-4 to come up with, let's call it self-similar data, but in a huge quantity. But of course, if you have enough data in your company, you do not need to go for the synthetic way. You can take, hey, I have here so many data. Think about you are Roche, you are a huge company. You have so many data, you can train your own model, of course. And this is now the third way I would like to show you. We call this instruction fine-tuning, and we use this for complex data. So, first way, second way, third way to fine-tune now your model on this particular data set. And now you see here, we do not need to go to GPT-4 for the synthetic data, but we have now in our huge company, for example, our secret data that we do not want to put in the internet. For example, you have quantum chemistry. You have a lot of data about your quantum chemistry, a lot of information about quantum physics, and pure accident, you work here in the medical area and you have some secret data about the latest research development in pharmacology. So if you want to find new medications or new whatever you are researching for, you can combine physics, chemistry, and everything else we know about together and train this. Let's say there are 1,000 research paper here, 1,000 research paper here, and 1,000 research paper here, and you are looking for patterns. You are looking for common patterns, for interlinks no human has discovered yet. So you feed this kind of information here now over here, what we call instruction fine-tuning, we use for complex data set that have a hidden pattern structure. And we feed it either, now I would not recommend it, the smallest system, but if you are a mid-sized company, you can afford to rent here, for example, a model that has 30 billion parameters or 60 billion parameters. But you do not need this huge size for everything, for everybody, but you are just interested here in this particular data set. And you just want to train on with a strict focus on this data set for new medications, for example. You are absolutely fine with 30 or 60 billion trainable parameters since you only have one task, and forget about the political news, forget about architecture, forget about, I don't know, poems. You don't need this as in GPT-4. You can build your own highly dedicated system that is really focused and really powerful for only 1 or 2 tasks like those one. So you see, this is where we are today. We call it LLM Ecosystem of April 2023. And I just wanted to give you an overview that you understand if you hear wordings like PEFT or LoRa, that you understand what is happening, how is the interface between systems, what are public data, what are secret data, what are company data, what are corporate data that are highly protected, how is fine-tuning happening, how is in-context learning, what is the difference, and what are today more or less our three main methodology to take a little LLM system, the naked architecture, only the pre-trained version, and then invest in the fine-tuning for your particular corporate interest, for your aim, for your goal you want to achieve with this system. And the last thing I want to show you, if you are now taking the case of Alpaca from Stanford University, they paid in total $600 for the computer infrastructure. But you know what? Just to generate the data, they had to pay here OpenAI Microsoft $500. And then actually to run it on the compute infrastructure, on the supercomputer center, Microsoft, they only had to pay $100. So the generation of data, the value of high quality data, in this particular example, the data are 5 times more valuable to generate them, to have them, than to run here the operation in the supercomputer center, that you do the calculations and you build up here this specific artificial intelligence for your dedicated task. So you see, data compared to run supercomputer to create a specific intelligence, 5 to 1 in the case of Alpaca. So I think this is it for the first video. If you have any questions, please leave a comment in the description of this video. I hope I brought some idea and clarification, some understanding in the world, what's going on today. This is my knowledge. I like to share my knowledge with you, and I hope you enjoyed it.